One of the easiest ways to think about functions, especially those in the form of equations, is by thinking about them as four different categories: algebraic functions, trigonometric functions, exponential functions, and logarithmic functions. Each one of these categories of functions has different types of behavior. And I'm assuming that you have seen all of these categories before, so if you want more information, you can check out the optional resources that I posted this week that review some of the algebraic skills behind each of these categories of functions. I'm going to describe each of these different categories of functions, and then I'm going to talk about how we can combine the different categories of function to create new functions. We are going to use Desmos to visualize some of our functions. So let's start out with the algebraic functions. Algebraic functions are built from polynomials, and you should be quite familiar with polynomials. Think x squared, x to the 12th, and so forth. And algebraic functions are just adding, subtracting, multiplying, dividing, or taking the roots of polynomials. So for example, the square root of x squared plus 1. X squared plus 1 is a polynomial, and we are taking the square root of it. We could write that square root using a fractional exponent, and we could rewrite this as x squared plus 1 to the 1/2, because 1 is the power and 2 is the root. Another example of an algebraic function is x to the 4th minus 16x squared all over x plus the square root of x plus x minus 2 cubed times the square root of x plus 1. You'll notice that these functions look quite different. They have different domains that are really impacted by not having a negative under the square root and not having a 0 in the denominator. The important thing I want you to notice is that your variable, your input x, is in the base, and you have a number in the exponent. All right, the next category of functions are trigonometric functions. And trigonometric functions are really built from the unit circle. You might also be familiar with them with triangles. And as a reminder for the unit circle, a unit circle has the center of the circle at the origin, and it has a radius of 1. That's this blue line. Notice that we are in radian mode. This is kind of a confusing graph. But what you are looking at is a line, that red line, and the angle made between that red line and that x-axis. And for our trigonometric functions, our input for our function is this angle. And that angle is not measured in degrees for our class, it's measured in radians. And so you have a coordinate from where that line intersects with the unit circle. The x-coordinate is your cosine. Your y-coordinate is your sine. So if you're thinking about this as a function, theta, or this angle between this line and your x-axis, is your angle, and your output is what the coordinate is, either cosine or sine. So if I go ahead and graph these functions, I should use different variables there. I'm just using different letters so I can keep graphing everything on the same axes. And what you'll notice is I have my cosine graph, where my x-axis, my input, is my angle measure in radians on that unit circle, and my output is the x-coordinate. Then I have the sine function, where the input is that angle measure and the output is the y-coordinate. We have several other trig functions as well that it's important to know about. Tangent of x is sine of x divided by cosine x. Cosecant is 1 over sine. Secant is 1 over cosine. And tangent is cosine over sine. But you can construct all of the other trig functions from sine and cosine. All right, the third category of functions, which I think are the most important, are exponential functions. And the way that we describe exponential functions is the rate of growth is proportional to how much there is. And we're going to use this semester to unpack that idea. It will mean something very different to you by the end of the semester than it does now. Okay, so it's difficult to define exponential functions without using calculus, but I'm going to say kind of growing or decaying exponentially and hope you understand what that means. Many things grow exponentially. Population grows exponentially. The number of infected people at the beginning of a pandemic grows exponentially. And our exponential functions has the general form b to the x, where b is any number. B is your number. Now notice the big difference, and I shouldn't have used b here. That's okay, I'll change it in a second. The big difference between algebraic functions and exponential functions. Exponential functions has the x in the exponent. Algebraic functions have the x in the base. So let's look at an exponential function, let's say 2 to the x. Notice that it increases, and it gets steeper and steeper and steeper and steeper as it increases. If we want a number less than 1, then we have exponential decay. If our base is a very specific number, then we have a natural exponential. So I'm running out of letters here. And if we look at what E is a number, 2.71828, so forth. It's an irrational number. Okay, just a little bit bigger than 2, close to 3. So when my base is E, that is still an exponential function, and E is a number. Very, very important. All right, and finally, we have logarithmic functions. And logarithmic functions are the inverse of exponential functions. So they have the general form log base b of x. And that b is the same base as what I was referring to over here. So let's graph log base 2 of x. It is the inverse. It is flipped over the line y equals x of our exponential functions. The domain is all real numbers such that x is greater than 0. And if we try graphing some different functions here, I've already done with some different bases, you can see that the base determines how steep that logarithmic function is. If my base is e, then what I have is the natural log of x. So that is a very specific logarithmic function where the base is e. And so that is my exponential function, e to the x, reflected over that line, y equals x. Now this is a very, very, very big overview of these categories of functions. If you feel like you are not remembering some aspects of these functions, I would heavily advise you to look at those optional materials. You are not required to know all about these functions before we start the semester. We will be engaging with these functions, but the more foundation you have with them, the easier it will be for you. And we can create, kind of my big takeaway from this video, is we can create functions that are combinations of all these different categories. So we could add an exponential function to a trig function. We could compose a logarithmic function with an algebraic function, and so forth. And so we can start to combine them. If we understand what each category kind of looks like individually, then we can combine them and get some insight as to what they might do together.